When you are coming to the projection of the straight line, just before moving to the straight line, is there any connectivity from the point to the line? So we are at just beginning of the classes, we have discussed the point is a basic element of the drawing. So that's why we have started to understand the fundamentals from the projection of the points. So now is there any link from the point to straight line? Okay, the point line or any discussion about that one we may consider. So let that line, the line may be, we can just set out the points, the different people maybe define the different orientation. So once we can conclude the line as a set of the points. So when come to the set of the points, either set of the points can be expected as a straight line, cannot be. The set of the points may be, we may irregular, we may be definite radius, we may be a constant particular length. So that means the set of the points that depends on their arrangement, it leads to a curved line. If the curve is the very regular, then we make as a fixed radius line. The radius continuation we make circle. So like that the different orientation we may give with respect to the set of the points. So same set of the points we can consider the straight line. The straight line nothing but a shortest distance between you are consider. Suppose it is from one point from the second point. So we may just expect like this, we may set out the points, we can set, we may set like this, set out the points, the any orientation, so like that this also set out the points, all are nothing but set out the points. So what makes a straight line? So it's the shortest path. The set of the points is the shortest path between one point to the other point we are called as a straight line. So just now we have discussed about the points. Once you are learned the fundamental concept of the point, if you are just drawn the projection of the first point, if you are drawn the projection of the second point, if you are connected by the shortest distance, so then we can conclude it is the projection of the straight line. So in the previous case, the point whenever considered, we have discussed with respect to the first quadrant, second quadrant, third quadrant and fourth quadrant. So coming to the lines are as per our university syllabus or our national practice for engineering, we are suggested to practice first angle projection. In our study also, we are just concentrating to study all the drawings made by the first angle projection. So what are the first angle projection? Above the horizontal plane, in front of the vertical plane. So that means we consider a plane of reference represented vertical plane and we are saying it as a horizontal plane. So by the orientation, it is above the horizontal plane, in front of the vertical plane. So that area we can say as the first quadrant. Object were assumed placed in the first quadrant comes under the first angle projection. The point is the miniature spherical point we are considering. It doesn't affect any orientation. But when you speak about the line may be fixed line, some x length you are considering. With respect to the planes, suppose the same, you can assume this is a horizontal plane. In this horizontal plane, assume this as the straight line. I can keep the straight line like this one. I may keep the straight line like this one. I may keep the straight line like this. So there is a possibility of different orientation. Whenever the orientation matters, the respective projection also got changes. So that means the same line if I consider, the line may be, I can just draw like this one. I may keep like this. When I am keeping like this one, the respective view is this one, point only. I may place the same line like this one. When you are placed like this one, what about the front view? Previously front view has a point, now the front view has got the different changes. So that means whenever come to the lines, there is a orientation also matters to get our projections. The line may be same, the quadrant may be same, but depends on how we are positioned the line in the quadrant that makes you different front views and top views. So now what are the possible position the line with respect to a first angle? The first angle mean always it should be above horizontal plane and in front of vertical plane. This is the condition of the first quadrant. In the same first quadrant position, we can assume the different orientation. So what are the orientation possibilities? The first one, you may keep parallel to vertical plane and perpendicular to horizontal plane. In the second position, it may be parallel to horizontal plane and perpendicular to the vertical plane. In the third case, parallel to both vertical plane and horizontal plane. Next, fourth, parallel to vertical plane and inclines with horizontal plane. Fifth one, parallel to horizontal plane and inclines with vertical plane. The sixth and last possibility, inclines with horizontal plane and vertical plane. These are the different possibility of the position. The line may be same, the coordinate may be same. You are getting the different solution as per the line orientation with respect to coordinate. So possibilities parallel to VP, perpendicular to the HP. So what the first position we are saying? It should be taken a plane of reference. Now we are keeping the line such that it is parallel to the VP and perpendicular to the HP, like this one. So with respect to what you have to draw, always projections mean you have to draw the front view as well as the top view. So for the front view you have to draw the from, so suppose that's A and this is the B. So indirectly A is the one point, B is the other point. If you draw the projections of with respect to independent points, so A point you are getting projection as the A dash, the B point projection you are getting as the B dash. To get the solution, I may join A dash by the B dash by the straight line. So it is nothing but a front view. Similarly top view, so just I draw the projection of the NDA. So NDA you are getting as a projected here, B also in the same line. So both will be appears as a line. So that A is the, we are see from here, A is the visible point, B is just behind of that one. The single point mean if you are showing the only the point, so other person there is a question, what about the other point? So just whenever the point on the line there is a difference. Point is the only the single point is possibility. Whenever the straight line means the two endpoints we are having, you are showing the only the one point in the mark, but what about the other point there may be suspect. To that one, we are viewing from the top which is the visible, that will be keep open. So B is there but it is not visible, it will be merged with the same point. In that case, which is not visible, it has to be given in the bracket. So once you are representing the solution, you have to rotate it 90 degrees in clockwise direction. So once you are rotated, so what the view where can be get? This as the front view. In the same line of the front view, I may get the top view. So now this is A dash, this is a B dash, the A is visible, B is invisible. This is the first position. For the first position, parallel to VP and perpendicular to the HP. In the second position, I may assume, what the second position we are just now listed, the second position is parallel to HP and perpendicular to the VP. So parallel mean we have to just keep the line parallel to HP and perpendicular to the VP. So this is the line position. This is the A, this is the B. In the real time, points are identified as the capital letters. In the front view, respective lowercase with the superscript dash. In the top view, only the lowercase letter. If you drawn here, this will be independent. A point position is A, the B point projection is the B. Being the straight line, I may connect by the straight line and get in the top view of the line. Similar to get the front view, I have to draw from here. So where are projected, it appears as a point. But since it is a line but it appears as the point, you have to deviate to differentiate how the point to the line. So the 2 points to be identified. So while identifying, when you are viewing from which is the visible, that should be mentioned open. Which is exactly behind and not visible, that should be mentioned in the bracket. So once it is completed, it has to be rotated 90 degrees in clockwise direction. So then what the solution appears? It is XY reference line. So when it is moving down, so this entire plane will be comes. Being it seems as a horizontal, there is always confusion. So most of the students try to draw again horizontal. Check here, once you are rotating, what happens? Along the plane it will be comes down. That means along the plane including projectant, it will be comes like this one. Both will be in a same line. So now here, this is the top view with respect to front view you will get here. So being here A and this is the B, here A dash, B dash. This is the second one. Third position, in the third one, how the line to be placed? Parallel to both the planes. It has to be kept parallel to HP, parallel to VP. So this is the orientation. Now, respect to this plane is parallel, respect to this plane also parallel. So let us, it is the AB, its respect to front view, A dash and B dash, the respective top view. So both you are getting as a straight lines. Once you want to represent the above also you are getting a line. This is A dash and B dash. We know that front view, top view always in the same line. In the dash of A dash, in the B dash of you are getting B. Here I may get B. Being the parallel, you have to draw parallel. In the fourth one, So what the fourth one here having? It is line projection representation, that is a vertical plane and horizontal plane. So now this one changed. So what changed? It is parallel to VP but inclined with HP. This orientation. Let theta is making. So now this is the A point and this is the B point. So once you are getting the front view, this is A dash and B dash. This is the theta. So whatever the top view, in the same line here, here is the A, here is the B. So now what the change? Please observe here a small change what you are getting here. Suppose I am keeping this as a line, this as a plane. Whenever showing this as a parallel. So once I am keeping the parallel, if you have projected any length, end point is here, end point is here. Whenever the parallel, so what are the projected length? You are getting as the same length. So now assume you are making some inclination. So whenever making some inclination, what happens next? So now this is the line length. Assume this is of 12.5 centimeters. You are getting same 12.5 centimeters. If it is any inclination it is making, that means you are projecting mean end point, you are projecting mean like that you are getting the respective projection. So now whenever the inclination, you can check what the distance. Previously it was here. So now coming to the whenever there is an inclination, so what happens here? There is decrease in the length. How much now here? With this particular angle, I can get in the only the 9 centimeter as the length. If I am making the still increase, if I am making the perpendicular, so it becomes as a point. So you have to keep in mind one more point from here onwards. So what the point to be considered mean? Whenever there is a parallel, that respective dimension should be same. Whenever there is an inclination, the dimension will be get foreshortened. See here, it is parallel, so that's why the length you are getting as the same length. Being it is inclination, this point will be foreshortened. So how much foreshortened? Equal to, depends on this value. If this increases and increases and increases, becomes a perpendicular, so then what happens? This length also foreshorten and becomes as a very minimum point, that is a point. You have to keep in mind one fundamental concept. Earlier we have just framed the 3 rules. What are the 3 rules? Front view, top view, always in a same line. Front view is the projection on VP, details of HP. Top view is the projection on HP, details of VP. Now you have to add the 4th point. Wherever it is parallel, the respective projection is a true length. With that you have to catch that point. Clear? So just I am writing here. Whenever it is parallel to a plane, the respective projection is true length. This is very valid point. You have to observe the parallel. Whenever parallel, there is no disturbance in the object length, but because in the real time the problems mention the physical length. So which length to be protected by the parallel condition, based on that only you have to initiate to the solution. So very key point you have to keep in this point. Besides the 3 points, what are the rules we discussed, the 4th one to be considered. So now coming to here. So what the problem says? It is parallel to the VP. Parallel to the VP mean it is respective projection is the true length. So what are the projection on the VP? Front view. So front view is the true length. When you are drawing the front view is the details of HP. What the HP details we should represent? Whatever the above distance you have to take. Of that, whatever the inclination. Also in this problem we are discussing, it is making inclination with HP. So with that inclination you have to draw the primary view. So once you are drawing the primary view, we know that front view, top view is always in the same line. So by the indication, A should be comes on A dash line, B should be comes on the B dash line. So after that comes to the top view. Top view is the details of VP. So what the VP did by saying? It is parallel to the VP. So once parallel to the VP, you will get parallel to XY line. So now this is the A, this is the B. So that's why there is a very important and valid point. So what parallel condition must be observed so that you can initiate the solution. Why? Because you cannot draw this instantly. We know that whenever there is an angle, it will be becomes shorter. But how much shorter? We are not aware. You need not be take that much trouble by applying the trigonometric rules and find the solution, and by drawing that when it unnecessarily time waste. So by the graphical, we can readily represent our solution with lesser time. So for that, what you should know? You have to observe the parallel condition. Depends on parallel condition, you have to draw the respective projection first. So then move to the other side. By the basic principle, front view and top view comes in a same line. So this is the 4th condition. So what the 5th condition just now we discussed? It is parallel to the HP and inclines with the VP. So let me check again with the same respective views here. Let this is the HP and this is the VP. So in this one, we are assuming a line. So what the line condition it is making? It is parallel to the HP and inclined with VP, like this. This is a pilot assume. So this is the A and this is the B. So by projecting, I can get this one same as the VP angle. Now coming to the top view. So since it is a A and it is a B, this is the A dash, this is the B dash. Now coming to the view projection. So what the thing we are discussing, the front view, top view, always in a same line. Before that one, any problem you have to observe the parallel condition. So in this, as per the problem given, where it is parallel to the HP. So whenever parallel to the HP projection to be drawn first. Top view to be drawn. Top is the details of VP. So with the VP inclination, how much given you have to draw first. This is the phi inclination. So let this is the A and this is the B. So once you are identified, so then you have to move to the other view by the basic concept. Front view, top view always in the same line. So A is here mean A dash must be in this line. B is here mean B dash must be in the same line. So what are the details? Coming to the front view is the details of HP. What the HP details we are saying? It is parallel to the HP. So once you are discussing parallel, so you have to draw the parallel line from this end to that end. So like that you have to draw. So any solution, observe the parallel condition, it makes very easy things. So after that, the sixth and the last is a very complex position. We cannot draw that much easily. By the based on assumption, you have to proceed for that solution. So what that means? So whenever they given the plane of references, the line is making inclined with both the planes. That means if the line is like this one, it is making VP inclination as well as HP inclination, a little complex position this one. So it is making so like that inclinations. So which is making phi and which is making also theta. So in this problem, we cannot directly draw. Why? Because we are already evident whenever there is a angle it is making, the length is disturbing and length is becoming foreshortened. With the corresponding angle inclination, we cannot find how much it is foreshortened. So in that case, you have to move the solution by the assumption. So what the assumption? First assume parallel to vertical plane. Whenever it is parallel to vertical plane, already you know the solution, XY reference line. So parallel to VP mean I can draw the true length here. This is A dash and this is the B dash. So once a respective top view also I can draw without any problem. So next take the second assumption. So what the second assumption? It is assume parallel to HP. Whenever parallel to HP, I can draw the solution easily, readily available. So whenever parallel, true length will be there with the vertical plane inclination. So I am drawing the vertical plane inclination with phi inclination. Here is the theta inclination. So the corresponding, I can draw corresponding front view length. So after that, so whenever you are applying the logically, so actually solution like that, the line is making inclination with HP, inclination with VP. So whenever making, you can observe here on assumption, the end point will be always moves in a plane. So based on that condition, with the assumption, I am finding this as the top view length, I am finding this as the front view length. But where the end point should be? Always on the locus of the end point. So for that I am drawing at the end locus. This is the locus of point. This is the locus of point. Once you are finding the locus, we know that this is the front view length. But where the end point should be? On this line only. So for that take the compass. This front view length as the radius. Just draw the line. So where it meets. So that is the B point. So once you are getting the B point, the simply connect with the point. So which is the actual front view. Similarly, top view length as a radius, this point is the center, I can draw the line. So where it intersects, that point to be connected. So which is the top. So you can cross check. Front view, top view is always same line. So this and this must be comes in a same line. So all these are a complicated position compared to that one. This is the little one. So directly we cannot draw being the complex angle with both the planes. We know that physical length given in the problem is actual length, but we are already evident from the previous cases. Whenever there is angle, length will be foreshortened. When the length will be foreshortened, I cannot represent from where the top view or front view. So for that one, you are going for the assumption initially parallel to VP. So I can project with respect to projection front view. Next, second assumption parallel to HP, so that I can completely draw the top view. By the assumption, I can find the front view length, top view length. So once you are finding, take the compass and just transfer to the locus line, connect with the respective point, so that I can get the front view and top view. So now the sixth position, simple position to complex position we are identified. So based on all these 6 conditions, let me check the problem for solutions.